So we want to ask our viewers to think creatively and decide for themselves if the following three problems are to be solved with induction, and are those statements correct or are they not, and what really is going on. So be creative, think about it, and then try to prove your conjectures.
Okay.
So Brady, I'm going to ask you this question. Can I write number 13 as a sum of two smaller primes? So P1 plus P2. Well, you start, thinking about primes. The first prime that you pick up, 2, is actually going to work because there's going to be 2 plus 11, right? So 13 works. It can be written as a sum of two primes. Okay. How about 14? Well, let's see. 2 is not going to work. 3 plus 11. This is already working. Okay. 15. How about 15? Is 15 working? What is your answer for 15?
2 and 13.
2 and 13. Gosh, this looks very easy. Keep on. 16.
3 and 13.
Yes, 3 and 13. How about I go backwards? 12.
5 and 7.
Yes. 11. You cannot write it as 11 plus 0.
Right.
All right, so that is not going to work. Something's wrong with 11. Because if you have an odd number, in order to write it as a sum of two primes, right? Well, they can't be the same prime because that's going to give you an even number. And there's only one even prime. So you cannot have even plus even. You cannot have odd plus odd. So it has to be even plus odd, right? And there's only one even prime, which is 2. So if this is going to work, you must be doing 2 plus a prime number. And not all odd numbers are 2 more than a prime. What we saw for 13, that was the case. 13 was 2 more than 11. But 11 is not 2 more than a prime. And that was the problem. Okay, so this is not going to work for odd numbers necessarily. And we know exactly when it will work for odd numbers. But for even numbers? Let's try something random like, I don't know, 22. Is 22 going to work? Okay, we're thinking. 2 plus 20, no. 3 plus 19. Gosh, this is working, and maybe there are other ways to do it. So, for your personal amusement, try, can you write any positive even number as a sum of two primes? And this even number should definitely be bigger than 2 because you can't do it for 2. And don't try too hard because lots of people have tried. Not going to give you any more hints on that problem. But if it turns out that this is true, it is begging for induction, right? Is this really suitable, such a statement for induction? Because there are infinitely many ands, infinitely many statements here. Okay, next problem. Suppose we look at the polynomial n squared. Oops, here there is something. I'm just going to rewrite it here. N squared plus n plus 41. Okay. Is this always a prime when you input into it an integer greater than or equal to 0? Well, let's try. If I plug in 0, what do I get? I just get 41, which is prime. Excellent. Let's plug in 1. That's 43. That looks hopeful. Plug in 2. Oh, did I get it right? Yeah. 46. This is still prime. Keep on going. You may stop or you may not. Now, if you believe that this is always prime, is such a statement good for induction? If indeed it is true. It's up to you to decide. And final problem, we would like to represent natural numbers as pluses and minuses of distinct perfect squares. They are the perfect squares again. Okay, let me give you one example. Okay, how can I represent 2? How about minus 4, minus 1, minus 4, minus 9, plus 16? Is this going to work? 16 minus 9, that's 7 minus 5, that's 2. And these are perfect squares. This is working. Well, it's complicated, but 2 works. Let me give you another random one. 15. Okay. How about 1 minus 4 plus 9 minus 16 plus 25? You don't have to have any pattern. Yeah, there is a pattern here. And does this work? 25 minus 16, that's 9. 9 plus 9, that's 18. Minus 4, 14 plus 1, 15. So the question is, can you write any natural number as such a sum? If the answer is yes, can you prove it using induction or directly? Maybe there is a direct way. Just like splitting the squares into smaller squares, there was a direct way, and there is also an inductive way. So I'm going to give you a hint for those 3 problems in terms of the answers. One of them is true and provable. Another one is false and provable that it's false. And the third one, we have no clue. But it has been checked up to a gazillion number of cases, and it is true. So which one is which? And on this happy note, I wave you goodbye.
Each of whom is going to have a blue or a red hat placed on their head by an impartial referee who's going to flip a coin to determine whether I'm going to have a blue hat or a red hat.